I will start by creating a knowledge base. So I select File, New, Knowledge Base, and enter a name for this knowledge base. As the KB is being created, explain why GeneXus projects are called knowledge base, indicating that in GeneXus, applications are described instead of being programmed. They are designed according to the reality of the business being modeled. Therefore, the project becomes a knowledge base of the business. I'll start to describe and model the reality by selecting File, New, Object, or shortcut, Ctrl+N. Note that GeneXus includes several types of objects which, combined, allow us to model any application. In particular, to represent the entities of this reality, we use the transaction object. The transactions defined are used to infer the application data model in third normal form. GeneXus also uses the transaction object to generate the application program that will allow the end user to interactively insert, delete, and update records on the database. So, I create the order transaction. What are we going to record for a purchase order? A number that identifies it. Date. Customer's details. Set of products with their price, quantity, and line total. Invoice total. As you enter the attributes in the transaction, explain that as a good practice, a naming convention is used in which each field, attribute, is named with a prefix of the transaction to which it belongs. Use the period key to preload the name of the transaction when naming each attribute. Use the Enter key to add a new attribute. Use the Tab key to move between the attribute name, data type, and description. So far, I've entered the purchase order header fields and will now enter the lines. To do so, press Ctrl plus right arrow to add a new level to the data structure, or right-click and select Insert Level. Enter the fields of the second level. Create the price domain when defining the product price attribute. Domains allow defining data types in a centralized manner so that they can be reused. In this way, we increase the level of abstraction and ability to adapt to changes. For example, in the year 2000, the dates started to have the year modeled with 4 digits instead of 2. Enter the fields of the second level. And then press Ctrl plus left arrow to return to the header level and enter the data at the bottom of the purchase order. Select the Order ID attribute and set it as auto-numbered in its properties, shortcut F4. save the transaction. In this way, I've just created the structure of a transaction composed of two levels. 1. A basic level, order, where all the information needed for the purchase order header is specified. 2. A nested level, product, where the item data will be specified. Explain that certain fields should be calculated automatically, such as order product quantity and order total. To do so, we give GeneXus the formula to calculate each one of them. Also, I select the order product total attribute formula column and type product price times order product quantity. And do the same for the order total attribute and type sum parentheses order product total end parentheses. To view the data model created by GeneXus, I select the upper menu view and select Tables. As you can see, GeneXus has automatically created a normalized data model, with two tables to support the order transaction object. Order, order header, order product, order lines. This brings time and cost benefits thanks to the automation achieved with artificial intelligence. Before running the application, note that the web form was automatically created by GeneXus when the transaction structure was defined. This web form will be displayed to the end user when executing the application in a web platform. It will allow users to enter, change, and delete records, as we will see in a few minutes. These forms can be customized by the business analyst at any time. Web forms are built in an abstract web editor that will allow creating responsive web applications. To run the application, I press F5 or select Run in the toolbar. This screen that appears here is the database creation report. GeneXus shows the scripts that will be run on the database. I click on Create. Use the time it takes to run the application to reinforce that GeneXus will generate all the programs needed to run the web application, as well as all the programs to create and maintain the normalized database. When this process is complete, a web browser will be opened and a menu will be loaded with the objects created in GeneXus. The developer menu is an XML file that includes all the executable objects. It is a complementary menu for the GeneXus analyst to try the application. I click on the Order option to enter some purchase order records. GeneXus rules are the means to define the business logic associated with each object. They are written in a declarative manner, and GeneXus intelligently decides which rule to apply and when to apply it. Rules play a very important role in transaction objects because they make it possible to describe their behavior. For example, assigning default values, defining data controls, etc. Suppose that your client asks you that the date of a purchase order should be the current date by default. To do so, I will 1. Select the Rules tab in the Order transaction. 2. Add the default rule from the upper menu. Insert Default. 3. Complete it in this way. Default, parentheses, order date, comma, ampersand today, and parentheses. Now I'll add another simple rule to show an error if the product quantity is 0. I'll save the changes to see them in action. In this last interaction with the form, it was odd for us to have to type the product names all over again. Wouldn't it be better to have a catalog of products with their definition and price? This observation is correct, so we will change our system to have a catalog of products. In the current modeling, the product was part of the order transaction, but we understand that these entities should be independent from the order, and therefore they should be defined as a transaction. There is no problem with this, as GeneXus will maintain the normalized database based on the transaction schema. So, I'll create the product transaction. The product details entered in the order transaction are as follows. Product ID, product name, product price. Note that it wasn't necessary to define the data type of each one of the attributes, because GeneXus realized that they had already been defined in the order transaction. I save and click on Run. GeneXus makes an impact analysis and examines the changes that have to be made to the database according to the changes made to the transactions. Then, it indicates for each object the necessary changes. Note that GeneXus indicates that the product table has to be created and warns us, with a specification warning, that for the same product ID there may be several product name and product price values. It also indicates that it will have to delete the product name and product price attributes from the order transaction, because they will now be part of the product transaction and can be inferred through product ID. Remember that GeneXus maintains a normalized database, and that's why it wouldn't be possible to have a secondary attribute in more than one physical table. Once the data model reorganization is complete, when browsing the product transaction records, we can see the details of the products we had entered through the order. This automatic feature of GeneXus makes it possible to change the data model. GeneXus automatically changed the structure and mitigated the data from one table to another. But what happened with the product information that was stored in the order transaction? Note that the attributes that now physically belong to the product table are marked with a down arrow in the order transaction. This indicates that they are being inferred from the product ID attribute. Advancing a little further with the inquiry, we are told that the company has a customer directory, so it is not correct to store customer data as belonging to the order transaction. Instead, they should be modeled in an independent transaction. Customer details are recorded in the company's CRM system and should be taken from there to record the purchase orders. In sum, GeneXus makes it possible to integrate with any external system and take data from its database to use it in the system to be developed. To do so, I select Tools, Database Reverse Engineering, and enter the name of the database server and the name of the database to integrate with. Clicking on Next opens a list with all the database tables for me to select the ones I need. I select the Customer table. By clicking on Next, GeneXus indicates that it will create the Customer Data view. Note that it has added a number 2 to Customer ID and Customer Name, because they already existed in my model. If I want them to be the same, I need to indicate it explicitly. To do so, I select the customer transaction, and in the Customer Data view, I change these attribute names. Also, I need to change the name of the attributes in the index definition. Lastly, I'll delete the attributes I won't use from the customer transaction and the customer data view. I leave only customer ID, customer name, and customer last name. When the names are changed, the data view loses the content of the associated table property. Assign customer to it. I click on Run. Note that the impact analysis indicates that the customer transaction is associated with the customer data view, and that it won't be reorganized. That is, an associated physical table will not be created. After running it, we can see that there is a customer transaction that takes data from the customer table in the CRM system. Now, I'll show how we can generate applications with richer and more user-friendly interfaces. I'll apply the Work With for Web pattern and see its benefits in action. Patterns allow defining and encapsulating behavior automatically, as well as replicating it massively based on a definition template. Let's see an example. Suppose that in addition to inserting, changing, and deleting products through the transaction, we would like to see a product catalog. To make it more realistic, I'll add a photo to the product and apply the Work With for Web pattern. The image data type is one of those we call semantic domain, and which have their behavior implicitly defined. For example, this data type will provide a file chooser in the form to upload an image. There are other semantic domains, such as address, phone, email. When applying the Work With for Web pattern, provide an overview of how it is defined. Indicating that it allows adding new orders and filters, customizing the columns, adding actions, etc. When running it, note that the shortcut to the product transaction has changed, and now it is accessed through Work With Product. Note that GeneXus has automatically generated a new web page with a list of all products, from where we can search, insert, edit, delete, and view each product sheet. I shrink the browser, we can see that the application is responsive, adapting to the screen size available and prioritizing to show the most relevant information. If I click on the name of a product, its sheet will be displayed. There, we will see all its information as well as the information of related entities. For example, a tab with the purchase orders in which this product was included. This makes the application very user-friendly and easy to navigate, where all the information we need about the entity we are working with is one click away. Take a few moments to realize that GeneXus has generated all this with a single click. Now, I'll generate an application for mobile devices with Android operating system. The application will be generated using native Android code. The mobile application should have the following screens: menu to access options, list of purchase orders arranged in descending order. For each purchase order, the list of products included with their subtotal and total values. I'll start with the list of purchase orders. To do so, I select the order transaction and apply the Work with for Smart Devices pattern. After saving, I need to set a smart device object as Startup Object. In this way, when prototyping, clicking on Run will automatically start the application in the emulator. I locate the order transaction in the Object Explorer and right-click on Work with Devices Order to set it up as Startup Object. Indicate that if users have an Android device connected by USB to their computer with USB debug setting enabled, clicking on Run will automatically install the application on the device to try it there. This is very useful to make testing more realistic. I click on Run to have GeneXus generate the application for Android. While the emulator is being started, it may take a few minutes. Use this time to explain that GeneXus is generating all the programs, screens, and web services required to create the mobile application using native code. In this case, it is Android. Also, highlight that since GeneXus generates the programs, it makes us independent from any given technology. For example, when iOS changed its generation language from Objective-C to Swift, while many had to rewrite their applications, GeneXus users didn't have to do anything because the generator was updated so that applications could be generated using Swift. Note that GeneXus has created a screen with the list of orders. The date of each one of them is displayed by default. It is preferable that the screen title is Orders, that the total of each order is displayed, that they are ordered by date in descending order, that the contents of a line are vertically aligned. To make these changes, I will click on the List node of the Work with for Smart Devices instance of the order transaction and change the caption property to Orders. Drag the order total attribute to the grid. Change the label position property of the order total attribute and call it None so that the description is not displayed. Click on the grid and select the Orders property. Clicking on it displays a screen to change the orders specified. To fulfill this request, I change the value from ascending to false. Lastly, I change the vertical alignment property of both attributes to middle. I click on Run again to see the changes at runtime. We've seen how easy it is to change the content of the screens. Now I'll advance a bit faster and apply the design sent by the designer. Note that the first screen is an access menu with options. To this end, I will create in GeneXus a new object of Menu for Smart Devices type. To do so, I'll add an action to the menu for each access I want to have. Also, I'll load an image for it in the image property to include the icons sent by the designer. Two, list of purchase orders. Note that we want the total to be shown with the $sign and that it makes sense to use the same criteria for all amounts in the system. So I select the price domain definition and add a prefix using the prefix property. Also, the order total must be shown in bold. To do so, I open the object called Carmine Android of theme type. Themes encapsulate the definition of the component's appearance. For each type of component, for example, attributes, tables, grids, buttons, etc., there are several classes defined. I'll create a new attribute class with bold font to use it in the order total. Next, I right-click on Attribute, New Class. I call this new class Attribute Bold. GeneXus copies the definition of the parent class and allows customizing its appearance from the properties. And change the font weight property to bold. Lastly, I select the order list object and change the order total attribute class so that it uses the attribute bold class. I click on Run to see the changes. Note that the changes have effectively been made and that this screen already meets the aesthetic requirements. Product Sheet. The screen generated by GeneXus by default looks as follows. I open the Product Transaction, Section General to edit the screen. I'll make the following changes. Set the property label position equals none for the image attribute, and drag it to the upper part of the screen. Fit the properties of the theme class that the image is using, Image View. Select the theme and change the following properties of the Image View class. Margin. Use default, unspecified. Height. Use default, unspecified. Width. Use default, unspecified. Change the class of the main table containing the product sheet so that the dividing lines are not shown. I set it the table class. In sum, we've seen that from what we have already defined for the web system, structure and behavior, we can generate native applications for mobile devices, reusing the knowledge of the business encapsulated in the knowledge base.